So in this given figure, AB and CD are two parallel chords, and O is the center. So you can see the center of the circle. Okay. If the radius of the circle is 15 centimeters, okay, so the radius of this circle is 15
What is not
centimeters. You join,
live?
if you join OA, OB, OC, and OD, all are 15 centimeters. If you join this, you see the dotted lines here, OA, OB, OC, and OD. These are all 15 centimeters because these are all radii of the circle. Okay. So the next statement here is, if the radius of the circle is 15 centimeter, find the distance mn between the two chords of length 24 centimeter and 18 centimeter. So the length of these two chords are given to you. This chord AB is of length 24 centimeter, and this chord is of length 18 centimeters. So these two lengths are already given to you. Okay. You need to find out this. Okay. This distance mn. So let's see how to proceed. Now, if you see um, this line ON from the center is perpendicular to this chord CD. So therefore, it must bisect this chord. So we write, since ON perpendicular to CD, therefore ON bisects CD. And the reason is a straight line through the center perpendicular to a chord bisects it. Okay. This, therefore, and you know the length of this chord also. Therefore, CN must be equal to ND, must be equal to half into CD. And what is the length of CD given? It is given to be 18. So therefore, this is 9 centimeters. So therefore, this length I have got 9 centimeters. This length I have got 9 centimeters. Right? Now you consider this right angle triangle. You can also consider this right angle triangle also, no problem. Any one of the right angle triangles you consider. Okay. Let us consider this right angle triangle, ONC. In this, you see that OC is the hypotenuse, CN is the base, and ON is the perpendicular. You know the hypotenuse and you also know the base. Therefore, you can find out the perpendicular ON. So let us find out the perpendicular ON in triangle ONC. OC square is equal to ON square plus NC square. Okay. Put the values. OC is 15. ON, you have to find out. And NC is 9. The values. That means ON square is 15 square minus 9 square. So this is 225 minus 81. And 225 minus 81 is, I think, 144. Yes, 144. So therefore, ON is square root of 144, which is equal to 12 centimeters. Okay, so we have got the length of ON. Similarly, we can find out the length of OM also, this length. exactly similarly. How? Just as we have applied here, we'll apply here also. So see that OM is perpendicular to this chord AB. That means it must bisect it. This length is 24 centimeter. This will be 12 and this will be 12. Okay, so now you consider this right angle triangle. In this right angle triangle, you know the hypotenuse, you know the base, you can find out the perpendicular. So that's exactly what we are going to do. But we'll give our reasons here once again. So we'll write first OM perpendicular to AB. Therefore, OM bisects AB. Reason is a straight line through the center, straight line through the center of a circle, perpendicular to a chord, bisects it. That means what lengths do we have here? Therefore, we have AM is equal to MB is equal to half of AB. AM is equal to MB is equal to half of AB. The length of AB here, if you see, is given to be 24. So therefore, this will be half of 24, which is 12 centimeters. So you've got the length of AM, you've got the length of AM, and you've got the length of MB, and this OA is the hypotenuse. This is the base. You can find out the perpendicular. Let us apply Pythagoras theorem in this triangle. OA is the hypotenuse here. In triangle OMA, OA square is equal to OM square plus AM square. Okay. So OA square length, OA is hypotenuse is 15. AM is 12. We have found out. So this is 15. OM we have to find out. And this we have found out to be 12. Therefore, OM square is 15 square minus 12 square. 225 minus 144 will give you 81. That means OM is square root of 81, that is 9 centimeter. So we've got the length of ON as 12. So this length we have got as 12, and this length we have got as 9. So therefore, what is this? What is this distance? You add up the two. Therefore, distance between the chords MN is equal to 12 plus 9, or OM plus ON. Hence, distance between the chords AB and CD is MN equal to OM plus ON, which is equal to 12 plus 9, which is 21. That's it. That's your answer. Any questions on this sum? Any step that you could not understand? If not, then we can proceed to the next sum. The next sum that I want to do is number 10. And if you can do number 10, then you can do number 11 also. Number 10 has no figure, so you will have to draw the figure. In any problem, in any geometry problem, remember, if the figure is not given, you will have marks for drawing the right figure also. And as it is, if for any question in geometry, you will have to redraw the figure, even if the figure is given in your examination. Not only for your convenience, but also because you will have marks on redrawing the figure. In an overall, the marks that is given for neatness and all that, following instructions. Under that, everything falls. So even if the figure is given, you will have to draw the figure in your examination, unless I tell you not to. In your written examination, pen and paper examination. So number 10. The question here is ABC is an isosceles triangle inscribed in a circle. Inscribed in a circle means inside a circle with vertices lying on the circle. Okay. So ABC is an isosceles triangle inscribed in a circle. If AB is equal to AC is equal to 12 root 5 and BC is 24 centimeters. So what is given? All the three sides, I think, of the triangle are given. Okay, the two equal sides of the isosceles triangle are given to be 12 root 5, and the unequal side, third side, is given to be 24 centimeter. Question is find the radius of the circle. So let's draw the figure here. Write the question number first. This is number 10. So this is your circle, and let us inscribe a triangle in this. This is your triangle. Okay, ABC inscribed in a circle. And this triangle is given to be isosceles, so I can safely take these two sides to be equal. You can also take you can take, in fact, any two sides to be equal. Okay, so let us take AB and AC to be equal. So here AB and AC, the length are given to be 12 root 5. So this is 12 root 5 and this is 12 root 5 centimeters, obviously. And BC is 24. This length is given to be 24. Question is find the radius of the circle. Okay, now what is the radius of the circle? Let us say this is the center of the circle. Okay, so I write let O be the center of the circle. Let O be the center of the circle. Now, if I draw a straight line from O, if I draw a perpendicular from the vertex A of this triangle to the side BC, will it pass through O? That is my question. Yes, tell me. If I draw a perpendicular from A on the side BC of the triangle, will it pass through O? Or why not?
Yes, sir.
Why shouldn't it look like this? Why shouldn't it look like this? What is the harm in looking like this? What is the harm? If you see this does not pass
So,
through the line. Now you tell me.
so because the triangle is in between the circle, and if a perpendicular is drawn in an isosceles triangle, then it divides the base into two equal halves.
Fine, that is okay. But then why should it pass through the center?
So, because it is in the center of the circle.
So what? Hmm, that's not the reason. The reason here lies in the last corollary that I told you. See, this is your perpendicular, right? This is your perpendicular. It will pass through the center of the circle. Why? Look at this corollary. Let me just show you this. Yes, see this. You see this corollary? The last corollary that I gave you, deduction. The perpendicular bisector of a chord of a circle must pass through the center of the circle. You saw this. Now you compare with this. Now you see, when I draw a perpendicular from A to the opposite side in an isosceles triangle, if I call this point M, then these two must be equal, because any perpendicular that you draw from the vertex of the equal sides to the third side, it must bisect the third side. That I have told you already. Okay, and I told you this is something very important about isosceles triangle. So these two must be equal. Now once these two are equal, then what happened? This becomes the perpendicular bisector. AM becomes the perpendicular bisector, and according to our uh, this corollary, the perpendicular bisector of the chord of a circle must pass through the center of the circle. So therefore, this AM, being the perpendicular bisector, must pass through the center of the circle. Is the reason clear? Sonam, anyone has any question? I hope all of you can hear me. I'm not getting any response.
Yes, sir, we can hear you.
Okay,
Yes,
Yes,
sir.
sir, we can hear you. Yes,
fine.
sir.
So let us write this down. Okay, draw AM perpendicular to BC. Therefore, BM is equal to MC. Reason? Since triangle ABC is an isosceles triangle, since triangle ABC is isosceles with AB equal to AC. Okay, that means if BM is equal to MC, that means AM is the perpendicular bisector of the chord BC. AM is the perpendicular bisector of the chord BC. That means AM must pass through the center O, must pass through the center O of the circle. Center O of the circle. Okay, now once we have shown that this AM will pass through the center of the circle, now we can find out the radius. Okay, how? Now we can at least proceed to find out the radius of the circle. How? Now see that this length is 12 centimeters. This length is 12 centimeters because BM is equal to MC, right? If these two are 12 centimeters and this is a right angle triangle AMB, in which AB is your hypotenuse, this is your base. So therefore, you know two sides of a right angle triangle. You can find out the third side. You can find out the perpendicular, this, right? You can find out the perpendicular. Once you find out the perpendicular, um, once you can find out the perpendicular, this length, let us
Very
take
nice.
the radius of the circle to be, let us take the radius of the circle to be R. Then what will be this length? This length will be, since you know the entire length, this length will be entire length minus R. Okay, I have not calculated, but something minus R. So you get this length also, right? Now what you do is you join this. So this again becomes a right angle triangle in which this length is R, radius of the circle. You know this hypotenuse, you know this length. and you know this length also. Therefore, you can find out the radius. You will get an equation in R, and therefore you can find out the radius. Okay. This I shall finish tomorrow, not tomorrow, next week.